the new year. Guess I should check on Miss Gonzales to see how she's doing. Let's go give her a ring.
Ring, 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 ring.
I wonder who's calling.
Ring, 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 ring.
Hello?
Miss Gonzales, how are you doing today?
I'm doing great. How's your new year been, Mr. Williams?
My new year's going great, Mrs. Gonzales. In fact, I'm in the lab right now cooking up some exciting stuff for the kids in the near future. What are you up to?
Oh, I'm just in my classroom. Is that why you sound so close?
Actually, I think that is. Man, these state-of-the-art telephones are really something else. I wonder how they work.
I can explain that. Well, Mr. Williams, telephones use waves to communicate over long distances.
What's a wave?
Oh, a wave is just a transfer of energy that's passing through a medium or a vacuum. A medium is basically anything that's matter, a solid, liquid, or gas. Or a vacuum is the absence of that, or you could think of space. Mechanical waves need a medium in order to travel, whereas electromagnetic or EM waves can travel through a medium or with the absence of a medium.
Wow, I didn't know that there were so many different types of waves.
Actually, Mr. Williams, there are two ways in which waves can travel. The first are going to be our transverse waves. Transverse waves are going to have their medium vibrate perpendicular to the energy movement. When we mean perpendicular, we mean that right angle. So here's the resting position, and those waves are basically just moving up and down, or perpendicular to that resting position. On transverse waves, we have the amplitude. The amplitude is the height of the wave. It goes from your resting position up to the crest, or your resting position down to the trough. What's a crest and a trough? Well, a crest is the peak of the wave, it's the upper part, and then the trough of the wave is the lower part.
Can you show me what a transverse wave looks like?
Oh yes, I can.
Oh, cool! I see it where the material is bouncing up and down, but the wave is traveling back and forth. Perpendicular, just like you said.
Yeah, perpendicular.
And then you make a bigger wave by making a bigger amplitude.
God,
so it's almost as if you put more energy into it, the wave gets bigger.
It's like a tsunami wave. The larger the tsunami wave, the more energy there is.
Absolutely. Oh, wow. What other kinds of waves are there?
The second type of wave is a longitudinal wave. All right, a longitudinal wave is where the medium is vibrating parallel to the energy motion. On a longitudinal wave, this is like an example of a sound wave, it moves with compressions and rarefactions. So most of your energy is going to be found in the compression of the wave. There's a lot more energy particles there, they're more squished together, where your rarefaction, your particles are going to be spread out a lot more. When we talk about wavelengths on a longitudinal wave, usually we count from a compression to a compression. That would be one wavelength.
Can I see what a longitudinal wave looks like?
Of course.
Whoa! So if I compress and let go, I see the wave moving and it's in the same direction as the spring vibrating back and forth. Wow! Ooh, interesting. You said sound is a type of wave. I found these really cool things. They make a really cool noise when you hit them. How do you explain these?
All right, Mr. Williams, these are called tuning forks. With tuning forks, the different sizes represent different frequencies. For instance, this really large one has a frequency of 256 hertz. When I hit it, it's going to sound very low. In comparison, to the smallest one, which is 512 hertz. When I hit it, it's going to make a much higher sound because it's a higher frequency. When I hit it, you can see that the fork is vibrating. Those vibrations would be what are making the sound or the sound waves.
Wow, Miss Gonzales, that was a lot of good information. Now, you also mentioned electromagnetic waves. What are those?
Oh, so our electromagnetic waves are our light waves. Light waves consist of visible light and invisible light. The visible light is what you're seeing, all the colors you see, all that fun stuff. The invisible light's going to be like your microwaves, your x-rays when you go to the doctor. Those are what kind of make up the electromagnetic spectrum.
Oh, and then you also said they don't need a medium to travel through. That's how they're able to cross space and reach us from the sun.
Exactly. That's exactly right.
Gee, Miss Gonzales, that was a lot of good information you gave. Thanks for that.
Tune in next time for the next Trojan Science Weekly. Bye, guys.